In Chapter 2, you create your very first shell script. This is the chapter where we get all the fundamentals in place. We learn how to create a simple script, save it, make it executable, test it, and run it. I'll also introduce two built-in shell commands that are used frequently within shell script programming that you probably haven't seen before. Let's begin. So let's create for ourselves a basic script. To do that, we simply need to create a text file and put in it the names of Unix programs or commands that we wish to run in sequence. Let's have a look at how that might look. The three commands could be pwd to print the working directory, do a ls to get a listing of the files in that directory, and then print today's date. We might assume that these are three things that you might like to do collectively together in sequence frequently throughout the day. And rather than type all three of them together, you can put them in a script, give the script a simple name, and then type the name of the script instead. In order for these three commands to be executed as a script, those three commands need to be put into a file, and that file needs to be made executable. Now, if you can't remember how to make a file executable, you do that using the chmod program. Chmod is short for change mode. It's a Unix security program. I'm not going to go into the details of chmod just here, but I will show you how to make any program executable. This is how you do it. Let's say your script was called MyScript. To make it executable, you would type in chmod, then a space, then plus x, x for executable, and plus to meaning to add executable permission, then a space, and then the name of the file that you wish to modify the permission on, which of course in this case would be MyScript. Let's go and do exactly that. I'll do it on the screen, step by step, and I suggest that you, if you can, in your own unit. Firstly, we will create the file. I'm going to use the text editor Vi, so I'll call it Vi MyScript, like that. And as you can see, it is a new file. And then I'll add the lines pwd, ls-c, and then date. And that's it. Now I'll save the file and quit out of the editing session. And now, of course, the final step is to make the program executable. Again, I do that using chmod plus x, MyScript. Okay, I don't get any error messages, so it's obviously worked. Now we can find out how to run the script. In order to run this new file as an executable program, you simply type /MyScript. That is making the assumption that the script or the file MyScript that you want to run is actually in the current directory. It's in the same directory that you are. Let's break that down a bit. The dot means the current directory, and /MyScript means look for the file called MyScript in the current directory and execute it. Let's try that. Type in /MyScript, and we get three things. We get three lines. The first line is the current directory, pwd output. The second line is the output of the ls-c command. And of course the third one is the output of the date. So the script is working. Now there is a slightly shorter way of getting the script to run, but that depends on the fact that the directory that the script is in your path. If the directory is in your path, then you can abbreviate this further to just simply type in MyScript. Let's have a look at that. Now, how do I find out my script? Well, you'll learn this later, but if you don't know it now, type in echo $path. That'll tell me the current path. Now, what I'm looking for is this current directory in the path? Now, you have a bit of a look yourself and see if you can find whether it is or not. The answer is yes, it is. It's a bit of a trick question, actually. I know you can't see anything in that list of directories there. It contains the word course, which is obviously the name of this directory. But here's a little known fact: if your path begins or ends with a colon, then your path is said to include the current directory, either at the beginning or the end. So the MyScript program is actually in the current directory, which means it will run if we simply type in MyScript. So let's do that, MyScript, and there it is, exactly as before. Now, all of that I just did depends on you having a reasonable understanding of what the path is. If you didn't understand what the path is, then all of that stuff I did with the echo path and all that sort of stuff would have been quite mysterious. Never mind, we are going to cover the path in enough detail in one of the next few modules. What I really wanted to show you in this particular chapter is that if your path is set up correctly, then you can execute the shell script that you have created simply by typing its name. You don't need to worry about the / at the beginning of it. Let's move on. It is important to note that absolutely any Unix command may be added to a script. That means that anything that you can type in on the shell command line can be put into a script. Absolutely anything. And the reverse is true, and most people neglect to realize this, that any lines of text that you find in a working Unix shell script can actually be typed on the shell command line, and they'll work just as well. And that includes obscure things like if statements, loops, comments, and so on. They'll all have the same effect on the shell command line as they did in the script itself. Now, what we're actually going to be looking at for the duration of this entire course are special internal shell commands and features of the shell that have little use outside scripts. In other words, if you're a regular user of the Unix shell, you probably haven't encountered these commands and features yet. They're only useful for scripting. So the bulk of the course will be taken up explaining those. Obviously we'll also have a look at some Unix programs, such as test and expr, that were written specifically to be used in conjunction with shell scripting. And we're going to begin immediately. The very next module details one of the internal shell commands that you probably would not encounter if you weren't learning about shell scripting. It's called echo, and it is the subject of the next module. This module deals with the command called echo. Echo is a shell built-in command. We call them shell built-ins for short. This means that there is actually not an executable file called echo anywhere on your Unix system. Instead, when you type in the word echo on the command line or use it in a shell script, the shell processes that command wholly internally. No extra program is needed. So what does it do? Well, its function is very simple. It's one of the simplest programs there is. Any command line parameters of echo are written to standard output. If you like, they are echoed to standard output. It's a bit like a print statement, or if you're a C programmer, a printf statement. If no parameters are given, then a blank line is simply output. So, that's what it does. Now, why would we use it? What's the point of having it? Well, we primarily use it to display messages to the users of the script. Let's have a look at an example of that. At the $prompt we might type in echo, my name is Mark, and then of course the echo program would simply create one line of output called my name is Mark, whereupon it would terminate and the shell would offer you another command prompt. Let's have a look at some examples of where and how you might use that. Well, if we just use it on the shell command line by itself, it's not extremely useful. We can simply say echo hello there, and of course we get a line that just says hello there by itself. Echo by itself without any command line parameters gives us a blank line, as you can see. It's only when we start to use it within shell scripts that it actually becomes useful. Let's open up our MyScript program and modify that so that it includes a line of echo. So I might do it just here above the last line of the file, Now I might put the word echo in there as well. The current date and time is, and then a colon, and then of course we would get the date. And right at the top we might do a similar thing, except instead of saying the current date and time, we might say directory, like so. Okay, the file is saved. I'll now quit and run it again. And this time I get 5 lines of output, the current directory, which is then followed by obviously the current directory, then the contents of the directory, and then the current date and time. Now it's still a little bit bunched up, so let's try again. Let's go back into my script and do it a little bit differently. After we do the pwd command, let's do echo, and then that'll create a blank line, and then we can say the contents of the directory are, and then that, and then we'll do another blank line just to separate the 3 different outputs. And let's save that and run it. And now the output's looking a little bit more user-friendly. Rather than 3 unexplained lines simply appearing on our display, we've broken them up now into 3 different sections, and each section has been explained, all through the use of the echo command. Echo also comes in very handy when we're displaying the value of variables, but we don't know what variables are yet. We'll have to wait to the next chapter or 2 before we discover variables. Anyway, that's it for echo for now. Hand in hand with the echo command goes the read command. If echo can be said to be the command that prints output out to the screen, the read command is the command that reads input in from the keyboard. Just like echo, read is also a shell built-in. It reads exactly 1 line of inputted text, usually from the keyboard, but to be more precise, from standard input, and it stores any information that it reads in shell variables. Now again, we haven't exactly covered shell variables yet, so we're going to get a little sneak peek of what they're like. The principal use of read is to receive the answers to questions and prompts that are issued by the script. Those questions and prompts would typically be issued using the echo command. So how it works is we typically echo some question out, like what is your name, and then read the answer using the read command and store it in a shell variable. Let's have a look at an example of that. If you issued the command at the shell prompt read name, then what would happen next is the shell would appear to just sit there waiting. The cursor would be flashing at the beginning of the next line. But as soon as you type something, say your name, and then press enter, you would get your dollar prompt back again. You will get no output on the screen, no message indicating that anything has actually happened. The only thing you'll see on the screen is what you have actually typed. But the clever part is that you now have a variable called name, and that variable contains the value that you typed in this case Mark Virtue. If you ever want to see the contents of that variable displayed on the screen again, you can see them by typing in echo and then a $sign and then name, which of course goes back to our echo command. Notice that you have to use a $sign if you ever want to extract the contents of a variable. We'll cover that in more detail later, just memorize it for now. So let's look at an example of that. I might type in read. Now I press enter, and the cursor just sits there flashing at the beginning of the next line. It's actually waiting for me to type something in. Now in this case I'll be typing in a phone number, but typically there's no way that the user is going to know what they're supposed to type in unless you precede the read command with an echo command describing exactly what you're looking for. Anyway, we didn't get that in this case because I'm just doing the read command, but I'll tie them together in a moment. And in the meantime, I'll just type in a phone number, 1 2 3 4 5 6 7 8. That'll do. And then I get my dollar prompt back. Now, I can now proceed to do any command that I want, ls or pwd, and at any time in the future I can determine what is in the variable called phone by saying echo $phone, and it will give me the contents on the screen of what is stored in the variable called phone. So let's now have a look at that in the context of a script. We'll open up my script again, and right down at the end of the line I will say echo please enter your name, and then I will read name, and then I will echo out a nice little friendly greeting, something like, if I could spell it properly, hello name, how are you? And let's save that and quit and run it. My script, and it gives all the same information as before, but now it's paused at the end saying please enter your name. So I can type in my name and it says hello Mark Virtue, how are you? The interesting part of that last example is the very last line, the fact that you can actually combine the contents of a variable with normal text. In other words, here is the contents of a variable, this will be replaced with the value Mark Virtue, and then that can be combined with just regular text like hello, how are you? That's a nice little feature of the echo command. Moving on, a little bit more about the read command. It's actually possible to break the line of input that was typed in by the user across several variables as follows. You could possibly do it as read first name, surname, and then the mark would go into first name and the virtue would go into surname. So you can actually read the contents of two variables simultaneously. What happens is the shell breaks up the line that you type in into little, what we might call chunks, and each chunk is separated by spaces and or tabs. Let's have a brief look at that as a working example. I might say read number, street, and type. This might be some way that I could read in the user's address, and I could type in 12 Smith Road, and then I find out that if I want to have a look at the contents of number, it's 12. If I want to look at the contents of street, it's Smith, and of course you can see what's coming next. If I want to see what's in type, it's road. So I've actually created, out of thin air, 3 new variables called number, street, and type, and filled them in with values. And some final points about that. If the user happened to type in more words than there are variables to put them in, then the extra words are added to the last variable. Now we've actually already seen that. The very first example we saw was where we asked for a single variable called name, and I actually typed in Mark Virtue. In other words, I typed in 2 words in response to one variable request, and both names, or both words if you like, were put into the single same variable. Let's have a look at the street example again, just to see if we didn't specify enough variables. If I typed in read number, street, and then typed in 12 Smith Road, then the contents of number are the same, and the contents of street are Smith Road. Okay, that's fairly self-explanatory, I'm guessing. And finally, if not enough words are provided, then the extra variables that didn't get filled just simply contain nothing. Let's have a look at that. If I type in read number, street, and then type, and all I type in response to that is 12, then I look into number and it contains 12, and I look into street and it is a mistake. I made a little mistake there. I didn't do it deliberately, but it is a good point that I can show you. If you don't put the $sign in there, as you can see I've omitted the $sign, then you simply end up echoing out the word street. Notice the difference between typing in echo street and echo $street is as follows. But anyway, back to the main point of this argument. We only specified 12, so street and type wouldn't have gotten filled in. So the same thing should have happened with type. It should be blank, and it is. So street and type were blank, but number actually got filled in with 12. Now, one final thing before we move on to the next module. This is actually a little feature of the echo command and has nothing really to do with read, but it's handy, so I thought I'd show it to you now. Notice how here the cursor is flashing on the next line. Wouldn't it be nice if the cursor was flashing on the end of the previous line? Let's have a look at how to do that. So if I just type in Mark, hello Mark, how are you, thank you very much, and now I'll actually modify this echo command here such that it will not jump on to the next line when the next command is executed, in other words when the read is executed. So what I do is I simply add a little -n there, and then when I run my script it says please enter your name, and now look where the cursor is flashing. It's flashing right at the end of the line, so I can just type in Mark and then of course as we are before. Now in the interests of completeness I'll show you how to get a little space immediately after the colon there, so the cursor is not flashing immediately after the colon, there's actually a space. So let's have a look at that. Now here's the clever trick. If you want to have extra spaces added, either at the beginning of the line, at the end of the line, or anywhere in the middle of the line, then you have to add, the whole thing has to be inside double quotes, like so. So let's have a look at that again, and my script, and now we've got a space after the colon. Now not all versions of Echo actually support that -n option, so I'll show you what to do if you encounter a version of Echo that does not support the -n option, and you'll know if it doesn't because the little -n will simply get echoed out to the screen. So I'll get rid of that -n. There is actually another option, and that is you can put a \c right on the end of the line as the very last character, but inside the double quotes. So let's see how that looks. Save and quit, and my script, and of course that works exactly the same way. So there we go. Okay, well that pretty much concludes the modules on echo and read. Let's move on. If you recall, at the beginning of the course I mentioned the prerequisites for the course and mentioned that they include a basic working knowledge of the shell. Well, there are some features of the shell that are not entirely what you might call basic, that are absolutely essential to the business of writing shell scripts. I would hope that people are familiar with them, but I can't assume it, and so I'm going to take out a little bit of time, and in this module I'll just make sure that everybody is aware of them. There aren't many of them and it shouldn't take too long, so let's have a look at that. The first one is the feature of the shell that allows any of the standard output of a program to be redirected to a file. An example of that is if you run the command called who, and then you put a greater than sign after the who, and then after the greater than sign you put the name of a file, then all of the output of that program will be what we call redirected into that file. it would normally, of course, appear on the screen. If the file already exists, it is overwritten. If the file does not exist, it is created. Now, whether it's overwritten or whether it's created, you actually have to have permission to do those things. To create it, you have to have write permission on the directory, and to overwrite it, you have to have write permission on the file. Let's have a look at an example of that. I could simply type in that example that I showed you on the screen just a moment ago, who type redirect into user list. Now we don't see any output on the screen, but if we cat the file called user list, we find that it contains a list of users on the system. Similarly, I could do the same thing with any other command like ls, and I could pipe that into a file called file list, and then if I cat file list, I find that it contains a list of files in the current directory. Now I'm not going to go into that in any more detail because, as I said, it's knowledge that you all should have already. Instead, I'll just move on and show you the rest of the features that I would also hope that you would already know. Very similarly to the first option, standard output can actually be appended to the end of a file rather than creating a brand new file. To do this, you use the double greater than signs. For example, I could append the contents of the etc password file onto the end of my existing user list file by simply using the double greater than sign. Let's do exactly that. If I cat /etc/ password onto the end of my user list file, I can now, I'll just do a little more on user list, and I find that the first couple of pages of it are a list of who's logged in, and then I find the actual contents of the etc password file, which is actually in fact a list of all the users on the system. Okay, so that's a little demonstration of the double greater than sign. Moving right along, it is also possible to what we call pipe the standard output of any program to the standard input of any other program, assuming that that other program actually takes standard input. For example, the who command could be piped to the wc command if you wanted to find out, let's say, in this case, the number of users that are currently logged into the system. Let's have a look at that. Who pipe to wc-l, and we find that there are 48 users currently logged into the system, including me. Now, for the pipe command to actually work, one of the programs, the one before the pipe symbol, has to create standard output, and the second of the two programs, the WC in this case, has to require standard input. Standard input, if you're not familiar with it, usually comes from the keyboard. So if I type WC by itself and just press enter, then it sits there waiting for me to type something. So I can type a little bit of nonsense on the keyboard here, and then finally when I press Control D, just so that you all know, Control D is the character in Unix, in all programs in Unix, that means I have finished typing, there is no more input. You can also think of it as the end of file character. So I type Control D, and then WC gives me the number of lines, words and characters that I typed. It's even possible to combine all these things together and say who pipe to WC and send the output to let's say a user count file, like that. So now we have a file called user count, as you can see, that will simply contain a count of the number of users in the system, along with number of words and characters as well, which will be meaningless information, of course. Also, similarly, it is possible to use the less than character to redirect standard input from any file into a program. An example of that might be if you had a script that required the user to type the answers to several questions. And if you wanted to automate the running of that script, you could put the answers to those questions into a file, and you might call that file answer file, and then you could redirect the contents of that file to the standard input of the script that you're running. So when the script asked a question and used the read command inside the script to read something from standard input, it would actually get the input from the answer file instead, and so the script would run without any user interaction. I can only show you a brief example of that. I've created a little tiny script called AskName, and I'll show you what's in it. It's just echo please enter your name, and then a read of name, so it will actually read something from the keyboard and then it will echo that name back out again. I've also created a little file called myname, which just contains that. Now if I run AskName by itself, then it says please enter your name, and I type in my name and it says hello. That's all very nice. And now if I want to automate that program so that it doesn't actually pause to ask me for my name, then I would run it as follows: AskName and get the input from the file called myname. And there we go, it says hello Mark Virtue. The program ran from start to finish without any interaction from me because all the answers came from the file. More basic knowledge that you ought to have: standard error is a separate output stream from standard output. In other words, programs can actually create two different types of output, and each may be redirected separately. Standard error may be redirected to a file using the two greater than symbol. For example, if you were to search using a program called find for a file called fred.txt, you might want to put all the results into a file called results, while you also might want to send any errors into perhaps a file called errors, and thus you would see no output on the screen whatsoever. I'll show you an example similar to that. If I was going to run the ls command and ask it to list the details of the file called userlist and the file called xyz, and I didn't have a file called xyz, then I would get an error message on the screen. So I get the error message xyz knows a file or directory, and then I get the normal message saying yes, well, there is userlist for you. That's his standard output, and the error message is standard error. Now I can do all of that again, but this time I send the output to a file called filelist, and I send the error message to a file called errors, like that. This time I get no output on the screen, and if I cat filelist, I just find that same standard output that I saw the first time I ran this program, and if I cat the errors file, then I find the error message that I saw the first time. So some of you probably weren't aware of that you can actually get two different types of output out of the same program, and they can both be redirected separately. It is actually also possible to redirect them to the same place if you use the 2 greater than ampersand 1 notation. Let me show you that. There is the file command that I just typed again, but this time instead of sending the standard error to the file called errors, I will this time send it to ampersand 1, which means I want the error output, output number 2, to go to the same place as standard output, output number 1. And so again I see nothing on the screen, but when I do a cat of file list, I see both the error message and the output message. Moving right along with other things that you may or may not know about, there is a special file on the computer called /dev/null, where any sort of output, either standard output or standard error, could be redirected if you don't need it. For example, if you were trying to find a file called mark.doc, then if you ran the following command, the results of the command would appear on standard output, while the errors would be sent to /dev/null, which means that they would effectively just vanish. Dev null is like a great big black hole. If you write some information there, you'll never see it again. Let's have a look at that. Here's the command that I just ran. Instead of sending it to file list, I'll send it to /dev/null, and now I get no output on the screen whatsoever. It is not actually possible to examine the contents of dev null because it is not a normal file. If I do an ls-l of /dev/null, I find that it is a special character device. I can tell that it's a character device because it's got the letter C as the very first letter of the ls-l listing. Also, it doesn't actually have a size. It has a 1,3, I think you can see, which is the major and minor device numbers, but I don't expect you to know what that means. Finally, and the last piece of shell basics that I'll show you, is that commands may be run asynchronously. To run something asynchronously means to run it in the background. And what that means is, if the program is going to take some time to run, then you get your shell prompt back immediately while the program continues to run. Which means, of course, that you can do a couple of things at once. An example of this is if you had a backup command that you wanted to run and you wanted to use the nohup command to run it. Nohup, incidentally, is a command that allows you to run any other program, and if you log off after you have started a program using nohup, then that program will not be killed when you log off. This obviously makes the assumption that you knew about the fact that if you're running a program and then you log off, then that program will usually be killed. You can use nohup to prevent that. Anyway, the purpose of this example is to show you that if you put an ampersand on the end of the command line, then you will get your prompt back immediately. And I'll have to give you an example of that. Suppose I run the interesting little program called sleep, and I say sleep for 1000 seconds, and it just sits there doing nothing. Now, if I wait long enough, if I wait for 1000 seconds, which I'm not going to do, then I'll get my prompt back. In the meantime, I'll just type Control-C, which will interrupt it. And now I'll type the same thing again, sleep 1000, and I'll put an ampersand on the end. So it's still going to sleep for 1000 seconds. That program is still going to run for quite some time, but notice I get my prompt back immediately. I also get a little number of output there, 16165, which is the process ID of the process that I've just started that's running in the background, and I can use PS to check that that is in fact running. There it is, 16165 is my sleep program. And in 1000 seconds of its own free will, that program will end, and then if I did a PS at that point, I would find there was only my shell and the PS. Okay, so that concludes the module on shell basics. I hope that you knew all of those things before. If you didn't, now would be a good time to go away and practice those. Throughout the duration of this course, it's useful to keep in mind that there are several characters that you can type on the keyboard that are interpreted as special to the shell. I'll show you the list of those characters now. They are the following. Each one of those characters has a special meaning to the shell. The shell employs each of those characters to do something clever or offer some feature to the user. Some of these I would expect you to know what they do already. In fact, I would expect you to know the meaning of the characters on the top line. Let's do a quick recap of those. The first is the ampersand symbol. That is used to run commands asynchronously or run them in the background. It also has another meaning which we'll examine later on in the course. The next one is the asterisk or star, and that's used in wildcard characters mistake, and that's used as a wildcard character in file name expansions such as star.txt or fred.star if you're trying to, say, move or copy or delete or list all files. Similarly, the question mark character and the next two characters, the square brackets, are also used as wildcard characters. Then the next two, the less than sign and the greater than sign, they're used to redirect standard input and standard output to and from a program. And the last one on the top line is what we call the pipe symbol or the vertical bar symbol, which is used to pipe output from one command to the input of another, as we saw in the last module. Now, the rest of them you'll be discovering throughout the remainder of this course. We'll discover the special purpose behind all of them. In fact, in the next module we're going to have a look at the meaning of the pound symbol or the hash symbol, which is the fourth one in from the left on the second row. But before we do, I'll just explain a bit about what you do with special characters if you need to use them. The first thing is that you should keep in mind avoid using any of these special characters when naming files. Now, it is possible to use these characters in file names. It is possible, for example, to put a $sign into a file name, but it's tricky to do so, and you're going to make a lot of work for yourself later on in life if you do. So the trick is to generally just avoid them. Incidentally, you should note, of course, that it is never possible to give a file a name that includes the / character. This character is not actually special to the shell, but it is very special to the operating system, when used in naming files. So the summary of that is you can't use the / character. You can use all the other characters, although I recommend that you don't. Characters like the full stop, the comma, the underscore and the dash, they're all fine of course and can be used whenever you want. Now more importantly for the scope of this course, if it's ever actually necessary to pass one of these characters as a parameter to another program, and it will become necessary, especially when we use things like grep and sed and so on, it is possible to do that. It is possible to, if you like, remove the specialness of the character as far as the shell is concerned, so the shell treats it just like any other character. And then of course that character is then passed in as a parameter to another program who will probably treat it as special in some other way and use it accordingly. Now if you want to do that, if you want to actually cause the shell to not regard the character as special just for the purpose of one particular command, then you've got to do one of three different things. You either prefix the character with a backslash. For example, if you wanted to cause the $ to be no longer special just for the scope of one particular command, then you would put a backslash in front of the $. Let me show you an example of that. If I type in that I want the echo command to run and I want the echo command to print out the following: the fee is $10, then I actually get the fee is 0. Now something's obviously gone wrong here because we're getting out 0 instead of $10. Now I know what's gone wrong, but I wouldn't expect you to know what's gone wrong just yet, so I won't explain it to you because it'll only confuse you. What we do know is that the $ is being treated as a special character. So instead of using the $ as its regular special character, I'll remove its specialness and I'll do exactly the same thing and say the fee is $10, and then we get exactly what we want. The $ is no longer treated as a special character for the shell, so it is passed in to the echo command, who just prints it straight back out to the screen for us. The second way to remove the specialness of a character is to surround the character with a pair of double quotes or rabbit ears or whatever you want to call them. And you should note that this actually doesn't work for all of the characters. In fact, it doesn't work for the $, but it does work for just about all the others. Let me show you an example. If I wanted to echo out the following words on the screen, comments begin with a hash character or a pound character. I'm going to call it the hash character for the remainder of this course. And I press enter, and I don't actually get what I think I'm going to get. I get comments begin with a nothing else. That's because the hash character is special to the shell. Wherever the shell sees the hash character, it ignores the character and everything else after it on a line. So the echo program is not even seeing the hash or the word character. All the echo program ever gets to see, all it ever gets passed from the shell, are the words comments begin with a, which it of course duly echoes straight back out to the screen. So I can fix that up by putting double quotes around, no, not there, and there, and then it of course works. The way most people do something like that is they simply put the double quotes around the entire text. They don't put it necessarily just around one character, although that will actually work, and so you get something like that. Getting back to our earlier example, if I was to put the double quotes around the fee is $10, notice that it doesn't actually fix the problem, because the double quotes don't actually remove the special meaning of the $. There is another technique that we can use to do that if we don't feel like using the backslash character. That third and final technique is to surround the character with a pair of single quote characters or apostrophe characters, and you can do this for every character that there is except for, of course, a single apostrophe itself. Here's this command again, now with the single quotes, and of course that works perfectly. Notice that the quotes never get actually echoed out themselves. Okay, well that's just about all you need to know about special characters at the moment. You will find them to be extraordinarily painful to use sometimes when you're using them in conjunction with sed or grep or some other character mistake. or some other command, it's often difficult to know where the double quotes or single quotes need to go, or whether you need to put backslashes and how many backslashes you need to put in place. That's all ahead of us, and we'll find all of that stuff out during the exercises. As promised in the last module, here is the module that deals with the hash character, often known as the pound symbol. The hash character is used to create a comment. So what's a comment? Well, a comment is a piece of human readable text that you add to your scripts to make the script more understandable. Inserting a comment into your script is like leaving a little note to yourself, either a note to yourself or to somebody else who happens to be reading the script, some other programmer perhaps who needs to understand how your script works so they can make modifications to it. Technically, a comment is any part of a line of a script that follows a hash character. In other words, when the shell sees the hash character, it ignores the character and everything else after it on the line, meaning you can follow a hash character with anything you like and it will all be completely ignored by the shell. Now, the way obviously that you use that is you put little explanatory text in there, little notes to yourself, little reminders of things that you still have to do, anything at all of course, and the shell will happily ignore all of it. Let's have a look at an example. I've accented in bold the two comments in the excerpt of text that you see below you. The first of the two lines begins with a hash, and so the entire line is just a comment. The second line actually does something useful, and then it has a hash afterwards. So the hash and everything else after the hash is ignored on that line. Now you can see that the first comment and the second comment both tend to explain what's going on. The first comment tells the user or tells the reader of the script what we're about to try and do, and the second comment explains exactly how we're doing it. Let's have a look at a more concrete, real, lifelike example. Here is a script that I wrote. It's quite a few lines long, it's several hundred lines long in fact, and it's completely uncommented, or rather it was commented, but I removed all the comments just to make a point. So if I look through this file now, I can scroll down a bit, scrolling down. Now, it may actually be obvious to some people what this script is doing, but then again it may not, and especially lines like that one in the middle there. So what we do is we add comments to that line, to that file, to make it more understandable. Let me show you exactly the same file now, but with the comments left in. And so you get a full description and so on. You get a description of every variable, see what the functions are, see what they all do, and little explanatory text surrounding almost every significant piece of code. So hopefully even people who don't understand shell scripting all that well will be able to tell exactly what the script is doing it, and perhaps even how it's doing it. That's pretty much all there is to say about comments, but I do want to stress before we move on that comments are vitally important. They really are. Any reasonably experienced software engineer will know that a fully uncommented piece of code is virtually unmaintainable. If someone gave me a 300-line script and said, I need to fix the bugs in this script or perhaps add some new features, without comments to explain to me exactly how the code was going about doing what it was doing, it might actually take me less time to write a new version of the script rather than try and figure out how the original software engineer developed it in the first place. The actual fix may have only taken me 10 minutes, but it may have taken me 3 or 4 hours to try and figure out where and how to make the fix, if there were no comments. Most people who've never programmed before, they completely ignore comments, considering them to be a waste of time. It's only when you come back 6 months later and pick up a piece of the code that you wrote and try and figure out how you did what you did, and this is your code we're talking about, not somebody else's, that you begin to realize how comments are so important. In fact, the irony of it is that comments are even more important when you're learning shell programming or any type of programming, because when you become truly experienced in your programming, you find it much easier to understand how a program is doing what it's doing. That's not to say that comments are no longer necessary. Of course they are, but they become somewhat less necessary. So, in a nutshell, you are strongly encouraged to comment all your code, all of it. And I'll say no more about that. Just to make sure that we're all at the same place, that everybody's capable of doing the same little simple basic shell scripting tasks, here are a couple of exercises. They're both reasonably challenging, so I expect that if you can get through both of these exercises all right, then you have a solid foundation as a shell script programmer. If you struggle with these, don't worry. I will provide worked solutions and I'll explain each step of the way what I've done and why I've done it. Anyway, here are the exercises. Firstly, create a script, hopefully fully commented, that prompts the user for their name, address and phone number. Now, once those details have been collected from the user, they should be stored in a file, and hopefully the file will look like this. Imagine, if you will, that those are the contents of the file. Now, it doesn't have to look exactly the same as that, but you get the general idea. We should have some text like the word name, and then the actual text that the user entered, like Mark Virtue. Finally, when the program has completed, display a message on the screen. This is on the screen, not in the file this time, but on the screen, that looks like this. The details have been stored in details.out. Now, you don't have to call the file details.out, you can call it anything you like, but what I would like to see in your output message is those little double quotes surrounding the file name, just to see if you were paying attention when we were talking about special characters. That is a little bit tricky, that bit. So that's the first exercise, and the second one is to create another fully commented script that produces the following sort of output. I'd like to see the number of users logged onto the system. I'd like to see that second. The first thing I'd like to see is the total number of possible users in the system, and finally the total number of processes running. Now, I'll give you some hints there. The file called /etc/password contains one entry for every user on the system. It is possible to use the PS command, process status command, to determine the total number of processes running, although I'm not going to tell you which command line option you need to show all the processes on the system. You'll have to look in your manual page for that if you don't know it off the top of your head. And the number of users logged onto the system you can find using the who command. As for how you count all those three things, well, I'll give you a hint. Try using the WC command. WC stands for word count, but it also counts lines and characters. Now, if you can, see if you can get the output to line up along the right-hand margin, like I've got the output lining up on the screen in front of you. I know that's not necessary, and it just makes the output look pretty, but it's a good idea to start learning those skills, because at some stage in your shell programming career, getting the output to look exactly a particular certain way is a task that you're going to need to do over and over again, so you may as well start now. Anyway, good luck, and in the next module I will explain the answers. Please don't look at the answers until you've at least had a go at doing both of these questions. I've also provided the two worked solution scripts in the Chapter 2 folder of the CD. Good luck. And here are the solutions to the exercises from Chapter 2. How did you go? Well, let's look at the solutions. Let's start with the first of the two exercises. I've called the script read details, READDETAILS. So I just type that by itself and it prompts me for my name. So I'll type in the name, Mark Virtue. Please enter your address, well, whatever. And finally a phone number. Okay, thank you. The details have been stored in the file details.out. Okay, well, let's have a look at that file, cat details.out, and there are the details as promised. So now that we've proven that the script actually works, let's go and have a look at the code. So we'll have a look at vi, what's it called, read details. Okay, notice that first of all we have a comment. First the user's name. So now I say echo, please enter your name, which is fairly straightforward, but I've put double quotes around the entire echo string, and the main reason that I've done that is so that I can get a little space happening just immediately after the colon, and also this \c, which means don't put a new line on the end of this line. So the cursor will remain flashing at the end of the line where I can enter my name. Those are the reasons that I've put double quotes around the echo string. And the next line is fairly straightforward, read name, and then it does the following, echo, and then it does an echo of the word name, and then the contents of the variable called name. Now here's the clever part, I have redirected the output of the echo command to store the output in the file called details.out. How did you go with that bit? It's not that hard, but if you'd never seen it before you may have had trouble with that bit. Now we do exactly the same thing again for the address. There's only one subtle difference, and that is right here, instead of using the greater than sign, I've used a double greater than sign because I want to append the echo's output to the file called details.out. I want it to go onto the end of the file. I do not want it to overwrite the contents of the file. And then again, exactly the same thing with the user's phone number. Now finally, display the message about the file name. And now this is all very straightforward, it's just a regular echo, but there's one clever little thing at the end. I want to have the actual quotes come out on the screen. Now the quotes won't come out by themselves. If I put regular quotes in there, then the shell will just remove them, treating them as special characters. So I actually have to make them not special to the shell, and the simplest way for me to do that is to put a backslash in front of each one. So there's a backslash double quotes, and then there's another backslash double quotes right there. And of course that serves the purpose. Now the second exercise, I've stored the solution in a script called counts, so I'll run counts now, and there are the details on this system. And yes, there are in fact 16,169 possible users that could be logged into the system. Currently only 48 of them are logged in, and those 48 people are running 207 processes. Notice that the output is all nicely aligned across the right margin. So let's look at the secrets to all of that in the file called counts. Again, we've got comments. Now here we say we've got a comment describes that all the users are found in a file called /tetra/password, so I cat the contents of a tetra password and I pipe them to wc-l. Now wc is the word count program, and it will actually, if you invoke it with no parameters whatsoever, it will display 3 different numbers on the screen, the number of lines, words and characters in the input. But I only want the number of lines. I only want the number of lines in that file, which will give me the number of users on the system. So I use the -l option, which says just the number of lines. Now the way I got all of that information to appear on the end of the previous line is, again, just like I did before with the echo. I put quotes around it, and I put a little \c on the end of the line, meaning don't enter a new line, so that the output of the next command will appear on the end of this line. And I use the same technique for all 3. Now again, the number of users logged onto the system, that's a very simple one. That's just the who command, and then again send the results to wc-l. Finally, the number of running processes. Well, on this version of Unix you can obtain that by doing a ps-e. It might be a different command line option for ps on your system, but it's -e on this system, e for everything. And again, the same thing. Now I've put a few little extra spaces in here, and the reason that I've done that is so that I get the output all nicely aligned, so that that \c, that \c and that \c are all lined up underneath each other, which means that the results of the wc-l will also appear in exactly the same column position. So the same technique is used for all 3. It's just 3 different commands, cat of etc password who and then a ps-e, and each one gets piped to wc-l and stuck on the end of the previous echo. And that's about it. How did you go? Did you get those out? Well, those were not particularly simple scripts to start with. I wanted to cover a great deal of techniques in just 2 little scripts. I could have posed a question saying, please write a script that displays the day's date and does an ls of a particular directory and so on, but that would have been too easy, and I think everybody would have known how to do that. So don't worry, I'm not going to make all the exercises at the end of each chapter quite so difficult. Okay, that's it. Let's move on to the next chapter.